wind out here is nasty this morning, and I've got to clean this mess up. Well, the battery was charging overnight, but I got mildly impatient with it and ended up running a cable into the shed anyway. So let's have a look. What did we get here? Come on. Load. There it goes. So we're at 55.6 volts. There is a little bit of balancing going on still, so they're not 100% top balanced, but it'll give us a good enough indication of how much capacity these batteries hold anyway, I think. I've regularly only charged the batteries to 3.45 to 3.5 volts as it is anyway. Some of them are slightly higher in voltage now than the other ones. Not sure if you can see that because I can't bloody see on the GoPro screen, but because I was using this 3.2 volt charger to bring up the lower cells, so I've sort of created a little bit of an imbalance now, because some of them are slightly higher than others, but it's not in a percentage that's going to drastically impact our capacity test. So just waiting for a mate to come around and give me a hand. Just waiting for a mate. And we'll move this battery out the front and I'll get it hooked up to the caravan. I'm going to have to put close to 2 kilowatts on it somehow, because yeah, if it actually has 10 kilowatt hours worth of power, and that wind is nasty, and the air conditioner uses 1100 watts, and we've got a 9-hour discharge time, you know. So I need to find a way to put more than 1 kilowatt worth of draw on it. That's okay. I've got devices I can plug into it that use up power. So yeah, we'll get it out, hook it up to the caravan. Hopefully start this test by 10. I really want it to be done by 4 o'clock this afternoon, so I need to discharge this thing in 6 hours if I can. So yep, I'll be back shortly. Right, bloody mess in here, but got the lithium battery wired in. So we've got the positive here and the negative there going onto the shunt. The other batteries from under the van are disconnected. The positive's still connected, but the negative is disconnected. So been looking for that battery charger. Leads come around here. Battery's connected. So let me just fire up the app and get some. Oh, phone into the light. So have a look. Come on. Alright, we're at 55.52 volts. Battery's fairly, yeah, cell deviation 0.07. That'll be alright. We didn't fully top balance, so I've wrapped some ad hoc insulation around that terminal block there, and we're on the positive at this end. What we did notice bringing it out is there is like 320 millivolts in the frame, which tells me that somewhere along the body here maybe the insulation's wearing through, or there's some power coming from somewhere that shouldn't. Either way, it's not ideal. So when I disassemble it, it might be a good idea to check for perforations in that. I mean, I know I scored the sides of it in some places, but I didn't think I did it anywhere where it's in contact with metal. So anyway, I'll figure that out. Alright, got cars coming past. I'll figure that out after the fact, and yeah, I mean, that's not going to impact the test today unless it catches fire. That would be ugly. Let's fire up the inverter. Is it forward? I think it's forward. No, that's charger only. Back. You gonna turn on? So, damn it. Because this is powered by the 240 volt, the servo, what it thinks is that the Venus OS device isn't turning on. So I need to, I'm going to need to give the Pi a separate power source, which is irritating, but here's what it is. I'll be back in a minute. One thing I do need to do, so I'm getting 55.2 volts there, so we're good. I've got to reconfigure this to match the amp hours. I don't have to change any of the other settings because it was a lithium battery anyway. But I'll go and grab a cord to run the Raspberry Pi off. I could run the Raspberry Pi off a power brick actually, might be a better idea. But yeah, I think just for longevity, I think I'll go and get a extension cord and run the servo off that, or the Venus OS off that, and then we should be good to go. Alright, inverter's on. We're discharging with 1.1 amps at the moment, so I'll quickly reset the settings on the Victron Connect app, and then, so I'm surprised that anything's actually running, because nothing's on inside the van. It must be, oh, it's complaining about grid lost. This has still got ESS in it from when I was using it paired with my big inverter. Did something similar to what Off-Grid Garage did, but we shared power by using the set grid point feature, which is not a Victron approved way of doing it. But right, we got the Caravan. Seems like there was a limit on the length of a name, because it's called Caravan Battery Ban. Oh, get out of it. I've got to do an update. I'll do the updates and I'll come back. So just like before, I think there's 600 amp hours in here at the moment in the Caravan, but we'll adjust this down so it's just 300 amp hours. Now the reason I'm doing that, sort of haven't thought about it before, is because I don't want it to go into negative numbers and potentially skew a result. Like, I don't know how the servo controller handles, well, sorry, Venus OS handles the like discharge, but you know, like maximum discharge was X. I'm not sure how they deal with that, but yeah, I don't want to not see it go above 200 if it's able to go above 200 amps of discharge. So we've reset all the counters. Inverter is on, battery is obviously on and discharging, otherwise the inverter wouldn't be on. I've got the keys to the van there. I'm going to go fire up the air conditioner and let's see this thing ramp on. What I will do is let's make sure that this thing's in VRM. Just give me 2 secs. I can see that the usage down there is on. So I'll just check my phone. Again, apologies YouTube, not that I don't trust you, but you know that if someone saw your unique ID for your VRM or something, they'd play silly buggers with it. We've seen that on other people's videos. So the Caravan is currently running our on-grid VRM instance, which is the one that used to monitor our grid-tied solar, which is why it's like, yeah, which is why it's called on-grid, obviously. The servo controller that's normally in here I'm using for that BMS development work. So we're good. It's reporting, yeah, local time, real time. All right, happy days. Okay, I'm going to go and fire up the air conditioner and I'll come back and we'll see how much load it's pulling. What have we got? 350 watts so far. The aircon will crank in a minute. That 300 watts is actually the fridge. So we bought this Caravan from George Day, told us it was a compressor fridge. Yeah, it's got 3 solar panels on the roof and a grey water tank. It didn't. It's only got 2 solar panels on the roof. And it's an absorption fridge, which is horrific on power. You don't really care when you got shore power, but when you're running on batteries you care. So pretty irritated given the cost of the van that we have to swap it out now. I'm not seeing the aircon kick in, so what I might do is I might go and set it to the lowest temperature setting it's got, so it starts pulling some power out. But what I do want to do is wander around and monitor with the IR camera the temperature of all the connectors, because this is ad hoc. I don't want to cause any fires. I should have realistically cleaned this mess up before I even started, but I haven't finished the Caravan, so this is just an ad hoc deviation from my plan. Alright, aircon's on, 1142 watts. I still need to find a way to pull more power than that, because that's not going to discharge. It'll take 10 hours if it has got 10 kilowatt hours worth of storage, so I need to find a way to pull more power. What I might do is go and get the kettle and might run the kettle in there just for like short intervals, because we're running through this power board, which is not going to be, I think I wouldn't want to run more than 1500 watts continuously through this power board. Oh, I can hear it. It's vibrating away. Alright, well that's it. It started, so I'll periodically come out here and try and use up more power on it wherever I can. I could switch off the MPPT and turn on some of the 12 volt appliances, and that'd add another 200 or 300 watts of draw onto the charger that's built into the van. So might do that, eh? Alright, I'll be back. I'll go get a screen capture of the Victron Connect from my computer, because it's probably easier to see what's going on from there, and I'll periodically flash one up. I missed it, unfortunately. I added some extra power consumption because I turned on the, I forgot the van's got an electric hot plate. So I fired up the electric hot plate to pull some extra power, and it was, but I did see some voltage sag. And I don't think the voltage sag was caused by the lithium batteries themselves. It's probably all the poor terminals. Like, I didn't have a crimper, so I've bastardised that crimp on this morning. Just for the sake of this discharge test, that'll be okay, but really you wouldn't do that in production. So I'm going to let it warm all the joints up and then get around with the thermal cam like shortly to see where maybe there's potential points of inefficiency going on. But I might interrupt the test to drop the cutoff voltage off on the inverter, because it's probably still set quite high. From factory they're set like at 1C they'll cut off at 50 volts, and I want this thing to come down to like 47. So it won't matter, because the statistics are calculated by this. Oh god, I didn't think of that. Shit. Let me see if I can close this, not all the way up because I don't want it to overheat, but enough that I can switch off my sprinklers. Let's have a look. Well, 40 amp discharge, so that's going to take 5 hours to flatten the battery, but there's definitely some voltage drop going on, because I got 52.9 volts at the BMS and only 51.8 at the shunt. So yeah, the issue is definitely somewhere along the line my terminals and the cable length are impacting this. So I will definitely need to drop the the voltage on the inverter, so that the inverter doesn't error out on us. But I'll rip into that. I've got my little multimeter with the thermal cam there, so I'll let these things sit for a bit, run for a little while at, was it 2.1 kilowatts coming out, and then I'll get around and check all the terminals. So we've got a capacity here of 12.1 amp hours that's been discharged, so I'll marry this up and we'll determine what the inefficiency is in using those long cables by what the Victron shunt sees. Since there's only one battery here and there's only one shunt, I feel like we should reasonably understand that there's probably inaccuracies in either one of them, but it should be a rough idea of what the percentage of loss is, you know, from the battery to the shunt. So anyway, we'll carry on with the test and see how it goes. Righto guys, just took me a little bit to figure out what was going on with my Venus OS device. The test is ongoing, but I have gone and adjusted. I used the VRM remote config to adjust the battery settings, so this will now take it down. It won't stop discharging until the battery gets to 42. So that's fairly low, so I'll probably intervene before then. Once I see the voltage starting to sharply drop off, I will, you know what I haven't done? Silly me, I have not recorded anything off the screen. Anyway, I'll go and do that, and you'll, yeah, I'll flash it up in the video. Well, since I reconfigured the voltage, we're looking good. We're at 53.9 amp hours consumed out of the battery so far. So if it's a 200 amp hour battery, we're just over a quarter of the way. Obviously this is saying it is only 20%, but that's because we set the power to 300 amp hour in the battery. Everything seems to be doing okay. I haven't checked with the IR camera yet, but actually, you know what? Let's do it now. I'm alternating between using the oven hot plate, and a sandwich press, and running the air conditioner, and that's how I'm discharging the battery. So that hot patch you're getting down there is actually the it's this tape. But what temperature we got there? 45 degrees. But again, that black tape is absorbing heat, so I think that's probably solar loading more than anything. And it's the black foam blocks on here that are getting warm as well, so I don't think we've got nothing to worry about. I'm trying to maintain between 20 and 40 amps. I'd like to go to 50, but alright, I'm going to get back into it. I keep forgetting that this thing's got an electric hot water system. Oh, the electric hot water system overloaded the inverter. Well, let me go and turn that off. Well, I reckon that sealed that deal then. I was toying with the idea of swapping this thing out to a 5,000 watt, and I reckon that's what we're going to do. 3,000 is not enough. Electric hot water system was on, the air conditioners were on, and a sandwich press, and that overcame the inverter. So it is warmer than 25 degrees here, so we're not going to get at 25 degrees Celsius. This thing should be able to maintain 2400 watts. It's warmer than 25 at the moment, so I'd say it's derated. But also the sudden increase in resistance on the battery leads probably led to a low voltage situation. So I'll go and look at VRM and have a look, but let me get the loads back on so we can carry on this discharge test and go from there. Alright, so without the sandwich press on, 1800 watts, and it's coping with that okay, so now we know. Yeah, I suppose if it's 30 degrees, which it probably is about 30 degrees, I'll go and check, but yeah, I suppose 2000 watts would be about right, constant load. This thing probably wouldn't want any more than that. That voltage is not sagging so much now either. So yeah, like combination of things there. Lead length, causing voltage drop, bad terminals, having additional resistance, etc. It's all going to add up. Anyway, let's leave it at that. We'll keep going with the discharge test. Well, even though the meter there says we're at 64%, obviously it says that because it thinks it's got a 300 amp hour battery, but it just cracked over 103 amp hours, which is yeah, like half what we expect the capacity to be. So I'm going to let's have a look at the battery quickly. Yep, so we're just cracked over 103 amp hours, which is 50% of the rated cell size according to the size of the original battery. Still questionable what size those cells are, who knows. We've told it they're 300 amp hour, but we're only expecting to get 200 out of it. So we're at 192 according to the battery, so that means there has been a percentage of loss there. Cell voltage difference is only 0.052, which I think is fairly reasonable. Obviously if we'd had the ability to top balance this pack, we could have avoided, we probably could have made that better, but is what it is. Anyway, oh, voltage cell differential just increased. Weird. Oh no, it's back down again, so we're all good. Alright, so we're halfway. Actually, we're probably, let's face it, we're more than halfway. If they're crappy cells, they're probably going to give up before they're 200 amp hour. But we might be pleasantly surprised, let's see. Get away from that big woofer. Oi, out the back. Go on. Get. Go on, get. So I just noticed from inside the house that, oh, we've got an overheat. We've got a low battery voltage, which is not an issue, but the inverter is overheated. Well, it makes sense, it's kind of warm in here. Alright. Now I know, right? I'm going to have to do something about that. So, I've got to get this thing to cool down somehow. We're at 149 amp hours, so I did notice that the voltage is starting to sag, like very consistently starting to drop off, which means that I don't know if we're going to get to the, it's jumped back up because there's no load, Inverter's just turned back on because it's obviously cooled down enough. We lost the one again. Okay, I'm going to have to do something about the heat load on this thing. Let me go and we're going to have to slow down this last quarter of the video. I won't put as much load on it, but this box is going to need some work done to it to get some air into it to make sure that this thing doesn't overheat. Well, you know what? That's just going to. I need to turn one of those around, don't I? See if we can do this without. That's a healthy sound. It's a good thing that these things don't matter. There we go. Get a bit of airflow going in there. Actually, it's not doing much, if I'm perfectly honest with you. I might swing those around because they don't do anything. Hopefully that's enough to get us through the test. Probably won't be, but what's the battery sag down to? It's down to 50.7. I did see it get fairly low before. It was down as low as 50.37. So anyway, we're at 32 amps now, so that's going to slow down the discharge test a little bit, but I think we'll still be done by 4 o'clock. So let's see what allotted time I gave for this, so I can pack this shit up this afternoon. Righto, we are at 49.8 volts. I've thrown these extra fans in to keep this thing cool. Slowed down the discharge rate because of it overheating, but it seems like, oh, I assume that's the aircon dumping its water out. Thought I was getting pissed on for a second. It's not that kind of a party, guys. Not that kind of a party. Anyway, let's have a look. So even though that's seeing a lower voltage, 49.8, the battery's actually at 50.83, which is pretty good. We have discharged 178.2 amp hours. Voltage differential is jumping between 0.08 and 0.057, which it has been at the entire discharge. So we've got 20 amp hours to go before we're at the rated capacity of the batteries, and I'd say at 50.83 volts, what does that work out to per cell? 3.178. There is plenty of capacity to go here. So unless there's a really sharp discharge, like fault drop off, we're going to be okay. I might actually push the current back up on the discharge closer to 40 amps, so that we're at 0.2 C, and we'll see how it goes. We are at the business end of this. We were just watching from inside. We're watching the voltage drop right off, 46.7, and we're at 195 amp hours consumed. So that's 195 amp hours consumed at the shunt, and the shunt's in here, which means if we go over the battery, I'd say we're on the money, I think. So come on. Where are we at? 199.1 amp hours of consumed capacity. So we're on a steep drop off in the voltage now. You probably wouldn't want to be getting it this close to the voltage on a regular basis, but I reckon, yeah, well, I'll keep an eye on it over the next couple of minutes, but once it gets to 44, that's it. It's done. Where are we at in the battery voltages? Lowest is 2.8, 2.9, so that's not so bad. We could bring it, yeah, we got about 100 millivolts to go in the lowest cell. The highest cell has got 200 millivolts to go, so 199 is our deviation, which is what we expect. That's not fully top balanced, so we could have got maybe 1% or 2 more if we had top balanced it, but I mean, shit, they did exactly the capacity. Well, we don't know that yet. It's got 199.9 amp hours consumed. We've got to let it go for 1.1. There it is, 200 amp hours. Done. I'm going to let it go for another 5 minutes. I've got my mate here to help me move this back out the back, get it out of the way. We have stopped an hour earlier than I expected. Yeah, we'll let it go for a little bit longer. I'll be back shortly. I'm down to 45.8 volts here. We've got a battery deviation of 0.262. Median battery voltage or cell voltage 2.8. I'm happy to call it there. I don't think we need to go any lower than that. We've got cell 7s at 2.6. The highest cell is at 2.93. So, like, that's it. That we know now. The battery cells were exactly what they said they were. They're not diminished capacity at all. At 202.2 amp hours. I could keep pushing this if I wanted to. We could probably top balance them better and get maybe 205 amp hours out of them, but that's it. It's just killed it. Oh, BMS kicked in. That fan's turned off now, isn't it? Yeah, that's it. So the BMS is cut in now, and it's not having it. So I'll go and grab the last of the Victron gear, but that more or less wraps it up. I'll grab that final screenshot off the BMS, and yeah. The VOLTX batteries, exactly the capacity they said they would be. Shit up, can't complain about that. So anyway, that ends that. I'll take this thing back inside, and yeah, I'll see you in the next one. Cheers.